Okay, ladies and gentlemen, here we are with the first installment of Chapter 2. Okay, this is for Pre-Calculus 10, and what we're looking at is an intro to trigonometry. Now, you may have heard of trigonometry before, but we are looking at in more depth today, okay, and for this whole chapter. So the first thing we have to understand is that trigonometry, basically, this type of trigonometry that we're doing is used for right-angled triangles only, okay, right now. And what a right triangle looks like, basically it has a 90-degree angle. You guys know that, right? A 90-degree angle. These are called legs of the triangle, and this is called the hypotenuse, right? So we'll call this the hypotenuse, right? And remember that this can be called A or B, and then this one can be B or A. Now, if I'm talking about A, B, and potentially this being C, then you'll remember that we can use Pythagoras to find missing sides, right? So we already know how to, we solve for missing sides, okay, for missing sides using what we call Pythagoras, or the Pythagorean theorem, okay? And you all know that as a squared plus b squared equals c squared. This is something that we've already used. If you're familiar with that, great. If you're not happy with that, then you need to work on that a little bit. Okay, so before we get into the nuts and bolts here, this is actually just an introductory lesson, okay? Get you used to what the hell it is that we're talking about. So let's look at a right angle triangle here. I'm going to look at a few different things, okay? There's a couple of conventions here. This side right here, okay, we can call that side AC. So let me draw another triangle here. If I call this ABC, this side could be called AB, okay? This side could be called AC, and this side could be called BC. That is one way to label sides, okay? Another way to label it is that we give big letters, so capital letters to the angles, and then we give smaller letters to the opposite side. So the side opposite this angle would be this one, and we call this side little a, okay? This is side angle B, shoot across. This we would call little b, okay? And similarly, boom, shoot across here, we'd call this one little c, okay? Just to keep things somewhat, just to teach you about the naming of these things, okay? Remind you of the naming of these things, because when we get into more difficult trigonometry, that's going to be very important to understand. Let's have a look here. So, one thing that I want you to understand as well is that in a triangle, right, we have three angles and we have three sides. What you need to remember is that all three sides or all three angles add up to 180 degrees, right? So all three angles in a triangle add up to 180 degrees. All right, so this angle, this angle, this angle, they add up to 180 degrees. Now, this already is 90 degrees, so you can see that angle A and angle C have to add up to 90 degrees as well, so that altogether they add up to 180 degrees. Now, one thing that we're going to deal with here, because a right angle triangle, think of it as a fixed triangle, okay? This is fixed, so you don't really have a lot of options, right? You don't really have a lot of options. If your angle is going to be right here, well, these are the different shapes of triangles that you can make, right? You can make them taller as well, but there's only there's not that many triangles, right? If there's a 90-degree here, then you are going to have a pattern developing, and you'll be able to make some predictions here, okay? Now, what I want to talk to you about is this. How about if I put a bunch of lines here, and looked at all of these triangles here, okay? See how there's one triangle here, so we've got A, B, C, let's go D, E, F, G, H, I, J, K. I'm going to get rid of this 90 here. So if we look at this, what I'm hoping that you see is that each of these triangles, so we can look at AED, or we can look at AGF or AIH or AKJ or ACB. What they are is they are all what we call similar triangles, okay? They all have the same shape, but they have a different size. Okay, they all have the same shape and a different size. If this angle here was 30 degrees, let's call it 30 degrees. Okay, then every one of these triangles has 30 degrees here. And if this is 30 degrees and that's 90, well then these all have to be 60 degrees as well. Okay, so they all have the same shape but a different size. And what that means is that all three angles are the same. Okay, all three angles are the same. And the reason that is important is because what happens here is we have three sides as well, okay? We have three sides. So we have this side here. Let me draw another triangle here for you, okay? Because there's a lot of things here that we have to look at. There's an angle. This is a 90 degrees, so that's got to be plus that is 90 degrees, right? And all three add up to 180. So if you look at this angle here, if we shoot across here, this is what we call the opposite side, okay? And we'll call it an O. We know that this is already called the hypotenuse. We know that as well. We'll call that H, okay? And this is what they call the adjacent side, okay? Adjacent, and that means beside. So we got O, A, and H. And what I'm hoping that you can see is that if we're going to compare sides here, okay, we're looking for ratios. Now, if you have a set angle like 30 degrees, it means that the ratios of the sides are always the same. And we're going to look at the height and the base first, okay? The height and the base. So what I'm trying to explain to you here is that this height and this base, if we compare the opposite to the adjacent, okay? The O over the A, that's going to be the same for every single one of these. So the GF over the AF are going to be the same, or IH, AH, KJ, AJ. Those are all going to be equal. So what we can do here is look at this. The ratio of the opposite over the adjacent will all be the same for any given angle, and what we use to represent an angle is theta. So what that means is that ED over AD will equal GF over AF, which will equal IH over AH, which will equal KJ over AJ, which will equal CB over AB. Okay, these are all going to be the same. And it's like that because you have a fixed reference point here for the 90-degree angle. So it means that for 30 degrees, that opposite over adjacent will be the same the whole way through. Okay, and these are the buttons that are plugged in on your calculators. These are the buttons, your sine, cosine, and tangent. These three buttons right here, they are the three sets of ratios, because not only can you compare O to A, what other ratios can you can compare this side to this side, or you can compare this side to this side. So you can go O over A, or you can go A over H, or you can also go the opposite over the H. So these are the three ratios. And it just so happens that this is the sine ratio, this is the cos ratio, and this is the tan ratio. And this is where the sine, cos, and tan come from on your calculators. Okay? And what I'm also going to show you are these trig tables right here that show you, okay, if I've got a 30-degree angle right here, right, my tangent ratio, which is my opposite over adjacent, is always going to be 0.5774, always. All right, so the beauty of this is that we can figure out the missing angles as well. Okay, we can figure out missing angles in these problems as well. And that's where we're going with the next lesson. So I suggest you watch the trig, section 2.1, the tangent ratio, and we'll get on this tomorrow.